Welcome back to N is for Networking, the show where we break down the wild world of networking, one piece of jargon at a time. I am Holly Metlitsky, your fresh-faced guide through the trenches of networking, and with me is Ethan Banks, who's been around the block quite a few times. On today's episode, we are following on from part 1 that we recorded about DNS. We covered some of the basics, how it works, and supposedly, according to Ethan, some of the cool stuff it does. But today, we'll be diving into a little bit more of those cool features and some other things that DNS does besides just the basics. So stay tuned. Hopefully, you can be won over by Ethan's cool comments on DNS.
Come on. I think, I do think DNS is cool. I've always enjoyed it. It could be one of my early jobs, Holly, was working for an internet service provider, and I had hostmaster duties, which back in the day was the job of your customers have domain names and they need help getting them out on the internet and updating them and stuff. And that was my job. You know, it was I was hostmaster at the name of the ISP.net. It was cool. And I've never gotten over it. I always thought it was fun. I like DNS.
I mean, that's very cool. That's being a hostmaster is a cooler name than, me just configuring a DNS server and calling it a day. So I can I can understand your interest and passion for it, but it's going to take a little bit of time in this episode to truly win me over. So
all right. So what do you remember from our previous conversation about how would you describe the fundamentals of how DNS works as a way of review before we talk about the other cool stuff?
Yes. I think in our last episode, I used the analogy of a phone book to explain how DNS works. And if you've tuned into that episode, you'll remember that in a phone book, you look up names to find numbers, right? So what DNS does is it uses a domain name to translate that into an IP address, because in the world of networking, we run everything in numbers and IPs. So, DNS servers help your device understand how to get out and resolve that name. We discussed a couple processes that happen along the way. So it's not just, your computer resolves the DNS and sends out that domain name and back comes an IP. There's a couple steps along the way. It goes through the root name server, which then points to the top level domain name server, which that's like your .com, your .net, those kinds of things. And then eventually you get to your authoritative name server, which finally provides that IP address. So that's the process we discussed.
I would describe that as the process of recursion. You're walking up and down the DNS tree. There's a bunch of servers involved, and that was important that the DNS was architected that way because it allows the system to scale globally and handle billions upon billions of queries a day. Otherwise, without all of that distribution of the workload across lots and lots and lots of servers, we couldn't have DNS. It wouldn't have worked globally, but it's one of those amazingly designed systems that is proved to be robust even in the modern era, even though DNS goes back decades.
Yeah. And the other thing we discussed, which I think will lead me into the start of this episode, is how to pick a DNS server and why certain maybe IPs for that are, I wouldn't say better than others, but maybe preferable for you to choose in your specific use case. And one of the things, Ethan, that you mentioned was that certain servers have an idea of perhaps some bad actors and which domain names maybe shouldn't be resolved. So bouncing off of that, does that mean that you can actually use DNS to use some sort of like content filtering on your network perhaps?
Oh yeah, 100%. In fact, that's a pretty standard offering for companies that are providing you with security services. And there's two ways that you can get a hold of a DNS server that provides you with some content filtering capabilities. If you're an enterprise, you're very likely going to look to your security provider to offer you that kind of a service, see if they've got it. There's a bunch of them out there. One that I happen to be familiar with is Cisco's Umbrella service. Mm-hmm. Umbrella is a lot of different security services, but one of the things that they offer is a DNS system that if you point to, you set up your DNS resolvers to be Cisco's umbrella DNS servers, they have a whole array of content filtering that they will do for you, so that when you got a host at your company that's asking for badguy.com, I'm gonna be you can't go there, and instead may redirect that client to a page that says, oh, sorry, blocked because reason, content filtering, or we know it's a bad actor, or you're not allowed to go to gambling sites on company time using company equipment, and so you get that block page. I mentioned Cisco Umbrella just because I'm familiar with it, and it's like so many Cisco services. It was bought by acquisition. I want to say the company was Open DNS that they bought, but to provide that service and roll it in. But that goes back a lot of years, and I'm not sure without digging around. Anyway, now just for people, like say you're not at an enterprise and you want to have the same sort of a service, but for your laptop at home, that's yours. Yeah, there's a bunch of services that'll do content filtering for you as well. So we talked in the last episode about Google's Quad 8 service. They've got Google's Quad 8, there's another IP address, 8.8.4.4, and there's also IPv6 servers if you're an IPv6 user, that the Google will do some content filtering there for you to protect you from some malware and some of the bad guys. Quad 9, which is 9.9.9.9, and then 149.112.112.112, and they've also got their IPv6's 6 addresses for their servers if you want. They'll do some content filtering. So will Cloudflare. We've talked to Cloudflare, again, huge internet company. They got the Quad 1 service and then 1.0.0.1 and their own IPv6 addresses. And then there's more addresses under there if you start digging into the documentation that will do specific things related to content filtering. Like, I think if you point to, I'm trying to remember, I got to pull up the documentation, but I think if you look at, I just pulled up the docs. Yeah, so if you look at 1.1.1.2 and 1.0.0.2 in the Cloudflare world, you can block malware. Those are very specifically targeted at malware. 1.1.1.3 and 1.0.0.3 in the Cloudflare world there, that'll block malware and adult content according to their documentation. So just pointing out that these services exist. Some of them come for a fee, some of them come for a fee. Some of them are free. Say that 3 times fast, and just know what the service is that you're getting into. But I've been using Cloudflare for a long time myself. It's very fast, and I trust Cloudflare with my data a little more than I trust Google. I don't trust either of them really, but if I had to pick one at the moment, I'm leaning Cloudflare because we kind of know what Google does with our. I mean, the Google business model is to take our data and do things with it so they can make money. Cloudflare is less that and seem to be very privacy respecting. So I lean towards Cloudflare. I haven't used Quad 9 in a while myself, Holly, but they are a nonprofit, and that sounds like they're probably on my side, but digging in, I haven't talked to those folks in a long time. I'm not sure where they're at. But yeah, so long way to answer the question, but DNS can definitely be used, used for content filtering. It's a big part of the service.
You mentioned IPv6 in there. Does IPv6 resolve the same way and with the same process that, IPv4 would resolve DNS? I would assume it does.
But there are parts of the world now that are IPv6 only, and so you can't reach a DNS server with an IPv4 address because you don't have an IPv4 address that got assigned to you. You're IPv6 only. Well, how are you going to do the name resolution? You point to an IPv6 based server instead of v4, and it works the same way. It's a different. When you get into dual stack, that is, you're running both v4 and v6, which is pretty common in the transition world that we're living in, where you've got v4 and v6 both on the same machine or on your phone or whatever. There are other services that will arbitrate between, well, which one should I use, and can figure those things out. Yeah, I'll mention Happy Eyeballs as a thing to go look up if you want to do some
Yeah.
research on how does my computer do DNS resolution, or how does it decide whether to use a V4 or a V6 service. One of the points of research that you can dig into to help you with that is just go look for Happy Eyeballs. It's going to come back with an RFC, an IETF, Internet Engineering Task Force, request for comments, document number. I think it's 7871. No, that's a different one. 8305. There we go.
Mhm.
Is Happy Eyeballs version 2. RFC 8305 will help you understand the nuances of exactly how your names are resolved and which one your computer ends up using if you end up having a V4 and a V6 address available to you.
Interesting.
All my answers are long. I'm sorry, Holly. All my answers seem to be long sometimes, but anyway.
Just how it goes. Now we're talking about security and content filtering and long things like that. One thing that popped into my mind is I don't even know if this is related to DNS, to be honest, but if you are in a web browser and you change that to a private tab, right?
Hmm.
How does that relate to DNS? Because if I think about it, you still have to resolve that domain name.
Right.
And perhaps it's just not stored in cache, but if you using a private web tab, is that still going through your ISP? I mean, can they still see exactly what domain name you're resolving?
What the private tab does in your browser, it is effectively making a container. It depends on your browser implementation, honestly, but
Mm,
what's basically happening is what goes on in your private tab is gone as soon as you
yeah.
erase that private tab, and that information is also not shared with the rest of your browser, all the other tabs in your browser. It's like, think of it like as an isolated process. Uh, so relating to DNS, we talked in the last episode about cache and how important
Yes.
caching is, right? Well, your browser has its own cache that's
Yes.
above and beyond and distinct from your operating system's DNS cache or a domain name server's cache. This caching, there's tiers of caching all the way down, lots of caching. I don't know, without digging into specific browsers and how they implement their caching, whether or not hostname cache is unique in a private tab versus the rest of your tabs, or if you get into tab containers, whether those are isolated from each other or not. It's an interesting question. And I can
Yeah.
see from an architectural perspective, like in my private tab, I don't want the cache shared with anything else on my browser. I want to keep those processes isolated. It's kind of like running a whole separate browser in a sense. But I know different browsers handle this in different ways. The way like the Chrome browser handles private tabs versus Firefox versus
Yeah.
what is Microsoft's now? They call it Edge, right?
I think it's
And
Edge. Yeah.
I don't know. And a lot of them use the same engine. Like a lot of browsers use the Chromium engine underneath. So a lot of those fundamentals are the same, but they skin it different and do, certain parameters are different in how they behave. So there's a non-answer. It's one of those, you got to dig into the browser specifically. That's a nuanced question. That is a subtle, nuanced question. If I turn up the private session in my tab, how does that affect my local DNS browser's cache? That's a good question. Doesn't have anything to do with your ISP's ability to see your DNS
Mm,
query, however, which is a point you brought up. That won't affect anything. Because the DNS query, if it's got to leave your browser, hit the operating
yeah.
system, and then go up and get resolved, if your your query's still out there. It doesn't matter where it came from, if it was sourced from private tab or
Yeah.
not, doesn't change that as far as that goes. Does that help?
Yeah. Kind of. I'm gonna have to dig into it and see how that all works. It was just a
Oh,
random question that popped into my head. Um,
warning. If you get into the privacy thing and you start digging into it, it's so much fun, but it's a rabbit hole that you will fall. It's definitely an Alice in
yeah.
Wonderland thing when you start getting into privacy and how to actually be hidden digitally on the internet, man, it's tough. It's tough, and you got to really know what's going on in your browser and how different services resolve things, and like why it's very hard to use Google services, for example, or Facebook services and remain private because they monetize all that data. They don't want you to be private. And so how they extract your data and use it, it's really interesting. It's really interesting. But to
Yeah.
be able to hide from those services is super tough. It really is. And there's a bunch of inconvenience you'll have to go through to truly remain hidden on the internet.
Yeah. I think I've
That's
come
a
to
different
terms.
conversation. I don't
Yeah, I
want to
was
get into
gonna
that. This is
say
a whole different, that's a different
very different
discussion.
rabbit hole. And I think I've come to terms with the fact that everyone just has my data and that's fine, whatever. Just, but I'm curious still. I'd
Okay,
like to
so
investigate the rabbit hole.
related to
Hmm.
this, if you're going to get into that, then you should also look up DOH, DNS over HTTPS, and
Yes.
DOT, DNS
Okay.
over TLS. Because if it's important to you to make sure no one can sniff your DNS traffic, because normally it's plain text. If you want to make sure it's
Hmm.
encrypted so that if it's sniffed, no one can read what host names you're querying for, look into those. DNS over HTTPS, DNS over TLS. A lot of browsers support that service now, and it is a way to obscure your DNS queries from anybody that might be snooping on it, except for the DNS server you're querying with the DNS over HTTPS service. I mean, it still knows. So you do have to
Yeah.
trust the DNS server you're actually hitting with the encrypted DOH or DOT sessions.
So that would be, improving your security on your client side. But as you just said, your DNS server would know. So is there any method of improving the security or privacy on that server?
Okay, so yes, and so there's lots of things that we can talk about here. If you're a DNS server administrator,
Hmm.
you of course would look at your DNS server as a thing that needs to be defended. You do
Yeah.
not want a bad actor to get in and have the capability of changing the IP addresses on your DNS server. And so you're going
Hmm.
to secure it with appropriate credentials, and you're probably going to I would do IP address filtering so that only an admin IP address an IP address block that is known to you and is authorized can hit that thing, kind of like you'd have a network management
Yeah.
IP block that you can only manage the router if you're coming from this IP address. Do things like that, and so on, and make sure you can audit the thing, and there's an audit trail for what's going on the DNS server and all the rest of it. So you want to do all those things. That's
Yes.
part of it.
Can you encrypt the traffic?
Which traffic? Like
Well,
the
like the DNS recursion process traffic.
so that specifically would be DOH
Hmm.
or DOT.
Okay.
Yes, you can encrypt that. You could also put that traffic in a tunnel between endpoints if you
Yeah.
owned that, like an IPsec tunnel that's
Hmm.
encrypted, something like that. But I mean, if you're on the internet and you're hitting a public DNS server, you don't have anywhere to build a tunnel to. But if you're
Yeah.
internal, you might be able to do some of that encryption. And there's that's a whole other conversation. That is a whole other conversation for sure. If you're just talking about just native DNS traffic, you could certainly encrypt the DNS management traffic that's
Hmm.
between you and there's a lot of DNS servers. There's going to be some kind of a web interface that you use to actually administrate what's going on in there. That's going to be HTTPS. That's going to be encrypted.
Yeah.
People aren't going to be able to like spy on that and see, oh, the admin just changed the IP from this to this, based on sniffing packets. That's possible, I guess, if you're using some older system that's plain text. But typically, that's going to be an encrypted sort of a transaction for sure. Um, okay, another security related service for
Yeah.
DNS that's worth bringing up. It's not worth getting into detail, but just to raise it as an acronym, DNS security. It is, oh man, it's really been a controversial topic, I would say. It has not been widely deployed
Hmm.
because how it was designed became such a headache for administrators to deal with that it hasn't really taken off. And I've even seen some arguments that are like, guys, we should just abandon DNSSEC. This is not working. From people that know and have reasons to have their opinions. But what DNSSEC is, it is a way effectively to cryptographically sign your DNS data so that what is inside of your DNS domain, your mappings of your host names to IP addresses and other such things, are using cryptography signed so that you know, okay, this is what it's supposed to be. It hasn't been changed in flight. There was no man in the middle that saw my traffic, changed the response, and then, sent it on, because the cryptographic signing key checks out and thumbs up. I know this is a valid response. But it's hard to implement. There's key expirations that you got to roll those keys over, which can cause DNS resolution to break. And there's other challenges that I remember along the way. I've never implemented DNSSEC myself, but read a lot about some of the headaches that people have had with it. But the idea is it's supposed to prevent those hijacks, the DNS, your domain either being hijacked by someone intercepting your query and rewriting the answer to something they want you to go to because they're the bad guys, as opposed to the correct answer, and so on. With the DNSSEC, you can prevent those sort of attacks if it wasn't such a pain in the butt to administrate. So that's a thing, for sure. Then one more thing, Holly, I'll mention here is, and this is going to sound really common sense. You're going to be like, well, who would do this? But the point I want to make is, don't make your internal only DNS like you're an enterprise, you're a company, you got your own internal DNS because reasons. You don't want to make that public facing. You don't want to make that so that the internet at large can query that, because the reason you've got an internal DNS is for your internal only resources that are not supported for internet browsers to go and access. You don't want them to get at that stuff. Because your internal stuff is internal. It's supposed to be secret.
But I guess my question there is, if you're creating an internal DNS server, wouldn't it by default be internal, and you'd have to manually set it up to be accessible to the public internet?
By default, yes. Have I seen scenarios where public DNS servers were out there, like specifically Microsoft Active Directory, Microsoft DNS servers? I don't mean Microsoft. I mean, you're running Microsoft Windows Server infrastructure internally with Active Directory. To support that infrastructure, you need a DNS server, so Windows Server DNS services, because that is how, in part, your Active Directory server services are discovered. They are known to DNS with SRV records and so on. You don't want to put that information on the public internet. I've seen it happen many times, where it could be because you're hosting it in the cloud and you made a configuration error. That is going to be more, because cloud can be internal, right? You can be hosting something in the cloud that is truly private just for your company, and you've got a direct connection, or you've got an IPsec tunnel that comes from your cloud VPC, virtual private cloud instance, back to it's just basically an extension of your data center, the way you've set it up. So even though it's using the internet to connect to it and using the cloud network to connect to it, and you're like, it's public. No, it's in a public network, but you're hosting it privately. So effectively, it's the same as an enterprise. But that's like, I've seen that. I remember browsing someone's DNS one day, me and some other guys, we were doing consulting. It's like, oh, that's their whole Active Directory infrastructure right there, public for us to check out. So, by default, would it be internal only? Yes. Can you screw up and expose it to the internet because you weren't paying attention to configuration, or you checked the wrong box, or you decided to do a NAT, or whatever it is you decided to do that exposed to the internet? Also, yes, that is a thing that I have seen happen multiple times. So be thoughtful about that, because what's in your internal DNS are internal IP addresses that give an attacker a great starting point. I know this server, and this server are Active Directory servers, domain controllers in their Microsoft environment I can go hit. Also, they're a Microsoft environment. That also tells me things I need to know, et cetera. So just be a little bit thoughtful about that.
There's definitely a lot of security questions or things to know when dealing with DNS, but there are ways and means and rabbit holes you can get into.
Tons
I
of them.
guess where I'd like to go is I want to know what your favorite thing about DNS is. Why do you love it so much? What makes you excited about it? If you can pick one.
There's so many quirks. Okay. So all right, there's a handful of like grab bag topics that we haven't hit. Let me pick a few that are fun. One is reverse DNS. So we haven't talked about reverse DNS at all, right? What do you think reverse DNS is? Just go by the name. What do you think?
I would assume I've got an IP address and now I need to get to the name, the domain name.
Exactly. So that is it's a very special domain name that falls under this. It is called the in-adder.arpa domain, in-addr.arpa. It's internet history, basically, why that is what it is. And it comes in the form of if the IP address you're trying to do the reverse of is, 192.168.0.1. The in-adder ARPA address would be 1.0.168.192.in-adder.arpa and gives you back the host name that maps to it. So that's a whole, just look up reverse DNS. It's another rabbit hole you can go down. That's fun. And what can be really fun about this is creative administrators you can make the reverse DNS host name be whatever you want. I want to know, I want the reverse DNS of this to be, I think you're having a nice day today, .mycompany.com. And I've seen some clever reverse DNS where you're doing a trace route. I don't know that we talk about trace route on the show, but trace route is where you're trying to figure out all the routers between you and your destination, and the trace route tool will like list them out for you with their IP addresses. Well, reverse DNS is happening there because you know the IP address of the router you hit, but you don't know its host name. And so a reverse DNS query happens and spits back that name. There are some clever admins who will actually tell a story, or there's reverse DNS poems that have been written because an admin built that in so that when you do a trace route, it resolves as a story, host name by host name, via reverse DNS. It's total internet quirk nerd stuff, but that's fun. That's fun.
That makes DNS fun. I'm buying into it slowly.
Yeah. Now I need an example, and I don't have one off the top of my head, but I know that's a thing. That definitely is a thing that's happened. I may have even been guilty of doing such a thing at one point in my past. It's possible. It's possible. Oh.
So I guess going back to that, does that mean you can actually create like domain names for any IPs that you have? If you've got a bunch of private IPs in your network, you could resolve to some domain name?
You can. And in the reverse DNS world that we were just talking about, you can have a lot of fun with it. It doesn't actually have to map to anything real. It can just be, whatever you want. If you own the IP block in question, it's been delegated to you, and so you're authoritative for that in-adder ARPA domain for that net block. That is a piece of it. You need to. No one's going to ask you to reverse DNS and give back a host name for an IP block that you don't own. You got to actually own the block. But if you're internal and you're using private IP addresses, I think we've mentioned RFC 1918, which includes the 10 dot and the 172.16 through 31 and 192.168 addresses. You own those in the sense that anybody owns those because you can use them internally, and so you can have super fun with your own internal DNS and in-adder ARPA for those RFC 1918 addresses, and just it's like an Easter egg. You're waiting for someone to discover it on the network and see what's going on.
There are a lot of those in the networking space. I know that within Junos, there's some command that you can run that gives you a haiku.
Yes, I'm aware of that.
Just because,
Right.
Which I feel like this is one of those fun things that if you have some spare time on your hands, why not? You can make a network engineer's day.
There's awesome ASCII art that's out there. You log into a system and someone spent a lot of time with high order ASCII characters to paint an image, or have a cool logo or something like that kind of shows up as an Easter egg if you know sort of thing. All right, so that's reverse DNS. Another kind of quirky thing that's worth knowing is about your local hosts file on your
Mhm.
computer. Whether it's Mac, Windows, Linux, you're going to have something called your host file. That is a static mapping. It's a text file. You can edit it and say this host name goes to this IP address. Period. Your computer will not care what the global domain name system thinks or will tell it is the correct answer because you programmed it into the host file and that overrides everything else. Why
Mhm.
would I want to do that? Well, most of the time you wouldn't. You wouldn't want to do that. But if you're a network administrator, it could be I'm standing up a new server and I'm not ready for the new server to be public yet. So I'm not going to update the record in DNS, in the public DNS, but I need to test. So I'm going to go
Mhm.
in my host file, update my host file so that the host name resolves to the new server so that I can do my testing. And then when I'm done my testing, I'll take it back out of the host file and rely on DNS again. Every system's got a host file. It lives in different places, all depending on what configuration you've got. But if you do a search for like Windows DNS host file, there's plenty of articles that explain to you how to get in there, how to edit it, and what the effect is, and so on. So that's a really good DNS trick related to host names to be aware of. Um, Here's another one for you, Holly. Have you ever heard? It's going to sound a little rude, but have you ever heard of a pie hole?
I have,
Mm-hmm.
but it's definitely been used. I don't know what exactly it is, but I've come across it.
So, so a Pi is in Raspberry Pi. So a
Yes,
Raspberry
yeah.
Pi is those little teeny computers. One board. They're super cheap, and there's lots of projects that you can run on a
Mhm.
Raspberry Pi. One of them is Pi-hole. It's a DNS server like we were talking about content filtering before. It's a
Yeah.
content filtering DNS server you can run at your house for super cheap. You get a Raspberry Pi, you throw a Pi-hole on there, and point your internal hosts to that server, and it filters out advertising. So if you like, I hate all the advertising that comes in on the web. My browser's just like crammed with ads, and it sucks. And sometimes pages crash because there's so many ads. It's awful. Pi-hole, that project, it's an open source project. You don't have to pay for that, and it is designed to filter ads that are coming in to your house. So yeah, and you don't have to run it on a Raspberry Pi, by the way. As I understand it, Pi-hole, you can run it in other ways as well. I don't think you have to have a Raspberry Pi specifically, if I remember right. It's been a while since I've actually looked at that project in detail.
Yeah, but getting your hands on a Raspberry Pi is pretty simple and they're fun to play
Yeah.
with.
Yep.
Fun fact,
Yep.
I
Yep.
had no idea what a Raspberry Pi was until I moved here. I don't know if maybe we didn't call them that, or I just never came across it like in South Africa and
Mm-hmm.
started grad school and everyone's talking about Raspberry Pis. And I didn't realize that it was like a piece of gear. And I was very confused, all this conversation about supposedly this pie or something.
Uh-huh.
So.
Yeah, they're cool. I've had a few. I've done a bunch of little projects with them over the years. Nothing I'm using in production right now, but I've tinkered with them. I got into using the pinouts on the board to drive a display, like a digital clock display
Yeah.
kind of thing, and figured out with some Python code how to put any number up there I wanted. It was a fun little project. Again, nothing I did anything with long term, but I had some fun hours messing with that. All right, another point worth making here is that we've talked about DNS as resolving host names to IP,
Yes.
and reverse, yeah, IP back to host names. But DNS can store all kinds of things beyond that. That's the primary thing it's used for. But there's all kinds of DNS record types that we haven't even talked about. The record types that we've been talking about are A records. These records
Hmm.
have letters that designate what record type they are. A records are the kind of records that map the host name to the IP address. If it's IPv6, they're quad A records, AA, not just A. Well, there's other record types too. Do you remember when we were talking about the process of recursion? I'm going to go to the
Yeah.
root name server, and it's going to tell me what servers can answer my top level domain. Now I'm going to ask the TLD top level domain servers, and it's going to tell me how to get to an authoritative name server. Well, those are a specific record type. It's actually giving you NS records, name server record types. It's a very specific type of DNS record that doesn't map a host name to an IP address exactly. It tells you this is the name, this is the IP address of a server that can answer the question you're trying to get answered. So NS records, name server records matter. There's text records, TXT. You can store all kinds of things in a TXT. It was literally a string of text you can store in DNS using the TXT record type. So for example, if you're a mail server administrator and you're adhering to the SPF, the Sender Policy Framework, which is part of security for anti-spam and proving that you are who you say you are and that the mail that is being sent is legit, you might have a TXT record that's got SPF information in it, Sender Policy Framework information. It just looks like kind of a funny esoteric record there, and various other things you can use TXT records for. We mentioned SRV records as how to find a server for a domain controller for Microsoft Active Directory, and there's more. There's more records like the reverse DNS record type. Those are PTR records, pointer records. So I say that just to make the point that there's a lot more record types than just host names to IP addresses. Oh, CNAME records. I didn't say the canonical name. If you have a name that actually points to a different server, like if you go to www.packetpushers.net, that's a CNAME that actually points to the final record, which is just packetpushers.net. There is no unique server www.packetpushers.net, but sometimes people still put www in front of things. It's like, well, no, it's just packetpushers.net. We don't really use www anymore because it's kind of old school, but I have a CNAME record in our DNS that points to the A record that actually resolves to whatever the specific IP address is. What else? There's so much cool stuff. Oh, we haven't talked about this. We've talked about TCP and UDP before, right? We've mentioned that as transport types. And what's the big difference between TCP and UDP, Holly?
One is one gives you an acknowledgement. There we go. Yep. It gives you an acknowledgement back. My brain malfunctioned briefly, but TCP acknowledges that the packet or whatever has been received. UDP, you send it out, and if it gets there, it gets there. And if it doesn't, well, you're not going to know.
Okay, well, DNS uses both TCP and UDP, all depending. For most queries, it's UDP. The average query where it's like, I need to know what the IP address is of this host, and that's UDP most likely. But TCP shows up too, depending on, there's different kind of communications. Like we were talking about keeping DNS servers that all serve the same domain in sync. Well, one of the ways that you can use to keep domain servers in sync is to do zone transfers between them. A zone transfer is literally the entire domain shipped from one place to another place. And there's limits on that. Not everybody can do it. Usually you're limiting it to other domain name servers that are hosting that same domain to allow zone transfers. It's a particular thing. It's an activity that's secured. Well, how is a zone transfer governed? Not UDP. It'll use TCP to do that sort of traffic. And there's other methods too, because you can get into, that's just if you go by the book, the traditional standard way. You had asked about, content filtering for DNS servers and stuff like that. Well, okay, take a step back from the content filtering aspect of it. And I'll just say that there are DNS server techniques and companies that make really unique servers that do DNS services, and the way they do it is kind of their own thing. So it's a DNS server where a standard DNS client can ask it a question, get an answer, but what's going on behind the scenes is freaking magic. It's definitely very different with what's happening back there. Infoblox is a company, they're very well known in the space of DNS and really a lot of other services too. But DNS is one of the main services that they deliver, and the way they keep if you've got a whole bunch of different Infoblox servers in your environment, the way it keeps all the data synchronized, it's their own magic. It's their own thing. It's cool, but it's not quote unquote industry standard, the way they do it necessarily. As far as I know, if there's someone from Infoblox listening to this and you're like, nah, man, we use all the same standard stuff that you were talking about. My bad. I'm an Infoblox customer from back in the day, and you guys were doing some different things. So if things have changed since I was last an Infoblox customer, my bad. Another thing that's kind of cool and fun here. I know you're
I'm
laughing
loving
at me.
this.
You're laughing, but
I asked the
I love this
question
stuff.
and I knew it was just going to be like this, like when you open one of those jars and like those gigantic squished up snakes like pops up. Like I knew that was where we were going. So I'm just like, I'm going to ask this question and just sit back and listen.
Okay.
So here we are. Keep going.
Okay. So here's another cool thing. If you get into DNS administration and you're at an enterprise, I mentioned like don't let your Active Directory DNS server be exposed to the public internet, right? So there's an implication there. You're going to have public-facing DNS and private internal-only DNS. That'll be which one are you supposed to use? Because you might be hosting the same domain internally and externally, but you're giving different answers depending on whether you're asking the question internally or externally. Yes. When that whole thing gets into some really interesting stuff as far as what's going on there. Because if you're inside your network, you're on the inside of your public firewall, you're running private IP addresses, probably those RFC 1918 addresses that I was talking about. That's a pretty, not the only scenario, but it's still a very common one. Well, if I'm inside the network, I want that RFC 1918 IP address to come back to me so I can get to the website or whatever the resource is. But let's say I'm outside the firewall. RFC 1918 addresses don't work on the internet. I need to get a public address to get to the website, let's say. How do I get the public address? Well, there's a lot of ways to do it, but you could be running two different DNS servers, one that's for internal and one that's for external. And you got to be, as your client, has to point to the right one or be able to get to the right one, depending on what the scenario is. It can get even sneakier. Firewalls, right? They do one thing on the inside, one thing on the outside, all depending on what's going on. One of the services a firewall does is something called NAT, Network Address Translation. Yep. Do you know what that's all about?
A little bit, yeah. So you converting your public IPs to private or the other way around?
Both, yeah. It goes both ways. Well, what if you're answering a question through the firewall so the firewall can actually see the DNS query that goes through. It knows where the client is and it knows where the server is and it knows whether the answer should be a public IP address that the client can actually hit or an internal IP address that the client can hit. But you only want to do this with one DNS server. The client can, or the firewall, can actually do a translation of the answer that's going on and rewrite it to be the correct address that whoever is asking the question can get an IP address that's reachable for them. And that's different vendors call this different things. Like in Juniper land, the SRX firewalls, they have all kinds of, I don't remember what Juniper calls them. I think they're fix-ups or something similar to that. But they have a whole bunch of services on the firewall that can look at traffic flowing through the firewall and go, oh, I got to rewrite the address. And so the answer it got back from the server was a public address, but they're not going to be able to hit that. I'm going to rewrite it to the correct private address. How does the firewall know what the private address is? Because you've put in network address translation statements in there that translate the public and the private. So it's got a table. I mean, it knows on the outside of the firewall, it's this public address. On the inside of the firewall, it's this private address. Oh, I saw the wrong answer go back. I'm going to, based on my NAT table, do a translation, for you. I mean, come on, tell me DNS is not cool. There's all kinds of neat things that go on here. This a bunch of fun stuff.
It's very cool. I think you learn about DNS literally just as, it's taking a domain name and creating and converting that into an IP. And that's boring. Like, that's just so basic. And then, we've now dived into 101 other things that go on behind the scenes or that, as an entry-level person, you're not going to know. And it's cool. It's exciting. This has been great. I've learned so much and you won me over.
I I wish we could talk more. There's a company that you should look up called NS1. They do super cool DNS stuff because they'll figure out what IP address to give you based on metrics like how close are you to this particular server versus another one, and it'll decide on the fly using a complicated algorithm which IP address to send you.
That's
DNS is
cool.
cool. Okay, DNS is cool. It's cool. It's cool. Okay, so here's my next question for you, Holly. But as we're wrapping this thing up here, do you have
Yes.
any of your own domain names that you've registered? You ever gotten into this?
I personally don't. I know my brother definitely has a bunch with every little company that he's kind of started, and I don't know if they
Guilty.
still
Yep.
exist. I looked
Also
into
done
it
that.
for like my wedding website if I wanted to pay for my own. No, but I could. I just couldn't come up with a nice punny name to make the URL, so I gave up on it.
I mean, go through the exercise, folks. It's a fun
Yeah.
thing. If you there's okay, so you've got services called DNS registrars. You need to work with a registrar to make your domain exist, and then to put the entries into like the TLD servers, so that the internet knows how to find the domain that you bought. That's what a registrar will provide for you. And you can register a domain for cheap, like less than $20, or more than $20, all depending on what domain you're going for. But typically it's cheap, and there is an annual fee, or you can get a discount if you're like, I'm going to buy this so that it's good for 5 years, and then in 5 years, if I want to keep it, I'll renew, and then you can have your own domain. Look at Cloudflare. Cloudflare will do this for you, and they'll host. You have to pay for the domain and have an annual. There's the annual fee to just keep it alive on the internet. Cloudflare will do that for you. Again, it's pretty cheap, but then just to host it there at Cloudflare beyond that is free. You can go in, you can set your DNS records, point into different things, and and have a good time. If you're wanting to experiment with this, it's a lot of fun, and there's a lot of back when I was a youngster. The only TLDs you really had were like the country codes and like .com, .org, and .net, and that was kind of it. There are probably a few other ones, but now there's a zillion of them. There's a zillion top level domains that you can have a lot of fun with that are more interesting. Like for a while, I had a domain that ended in .blog because I had a blog, and I had ecbanks.blog. That's dead. Someone's going to go out and register that now because I don't have it anymore. But it's I did.
You're going
I
to
had
start
that for a
blogging
while.
again, and you didn't even know.
I blog at packetpushers.net, right? So I mean, I just, that was a thing. As I did, like your brother did. I collected a ton of them and then didn't do anything with most of them. But and it's like, okay, I got to stop paying for these. There's $20 a year adds up. You know what I'm saying? So I collected a bunch of them. And if you're interested in doing this, go do it. It'll help put a lot of the ideas that Holly and I have talked about together. If you just go buy your own domain name and start figuring out. Last thing, Holly, the utility.
Yes.
Dig, D-I-G. It's a command line utility. It's very common. Go find some tutorials about how to use Dig, and it is a way from the command line to be a DNS client, query name servers directly, get answers back, and start making sense out of this stuff. It's going to look like a foreign language gobbledygook, but you can go ask a root server directly with Dig the answer to a question and see what answer comes back from it. That is a learning tool that is very powerful. Dig doesn't cost you anything. It's probably built into the operating system you have, or you can download it and run it for free. Dig, and go find a tutorial on how to use it, and you'll learn a ton. Super fun.
I'll add it to my to-do list.
Sure you will.
I'll put it at least in the top 5. Don't worry. Not at the end.
Okay.
You might never get to it. But now that I've gotten excited about DNS, I'm interested. So, yeah, I mean, thank you. Like, Ethan, that was great. We've been talking about discussing this topic for ages, and the whole time, like, DNS, he says it's exciting, but I don't know. And now I get it. And listeners, thank you. I hope that you get it as well. I mentioned, I think, in the previous episode that DNS is one of those things that's a little bit underrated, and doesn't get enough credit. So hopefully we've done it a little bit of justice, and you're just as excited as I am about the topic. You can go and use some of the things that Ethan has mentioned and dive into it and get your hands dirty. So I hope that you've learned something new. And if you want to give us another topic to cover, or you've got any questions or follow-ups, drop us a message at packetpushers.net/follow-up. We love hearing your feedback and love creating and adding to our ever-growing list of topics. If you'd like to connect with us, you can find us on LinkedIn. Just search for Ethan Banks or Holly Metlitsky and drop us a follow or connect. You can also join the Packet Pushers community Slack channel. This is totally free. There's a ton of people, a ton of content, a really great learning resource. You can find that at packetpushers.net/community, and I highly, highly recommend joining. And finally, if you enjoy listening or watching Ethan and I, please tell friends, colleagues, children, anybody who wants to listen and learn something new. We would really, really appreciate that. And just remember, networking isn't hard. Other people figured it out, so you can too.